Hello, welcome to a new episode of my tutorial on how to create a classic Metroidvania game in Unity. In the next section of this tutorial, I want to create with you, or I want to show you how to create a boss within your game. I will divide this section into 3 sub-episodes. In the first sub-episode, I will create the behavior patterns of the enemy and his movements patterns. In the next second sub-episode, I will create the damage system that gives damage to the player when the enemy is attacking. And in the third episode and final episode, sub-episode, I will create the damage system that gives damage to the enemy and at the end kills the enemy and the player can go on. We will conclude this into a prefab that we can later use on different parts and places within the game. But the first step for now will be that we take a look for animations. So here I'm on the itch.io page of the artist LuizMelo. We already download our hero from his 3 sprites. I think it will match the style of the game if we maybe get some sprites as well of the same artist for our enemies. So I selected those animations. I think they look very good. I will put the information about the link to the artist and to the asset in the video description so you can try it for yourself. And I would thank to the artist, and I already downloaded the sprites and we will use them and put them into our game. So let us create a folder within our Unity project. Within the sprites folder, we call that folder enemies, and within that folder we create a folder for the skeleton. Within that folder we can create a folder for animations that we will use later. Now let's go into our folder where we have the animations. We will copy those and drop them into our skeleton folder. And now, and you know the process already well, we set in the inspector of the animations, we set the pixels per unit measure to 16. We will set the filter mode to point now filter, and we will set the sprite mode to multiple. We will apply those additions, and now we go to the idle animation. We go into the sprite editor, and we want to slice it by grid by cell count, and we will type 4 cells here. We will slice that and apply those changes within the sprite editor. And you can see our picture dissolves now into 4 sprites. We will repeat this process for all other animations as well. Now we can use the idle animation, and we select the 4 frames of this animation and drop them into our scene. This will automatically create the animations. We will save them as idle animation within our animations folder, and this will also automatically create a game object called idle0 with an attached sprite renderer containing the first sprite within this animation and containing an animator. We will rename the game object to skeleton. So our next step will be that we create a new game object. We will call that skeleton. Skeleton object. Within the we will attach the skeleton here as a child object to the skeleton object. Let's put this ones to 0. Yes. And then we can change the position of the skeleton object, but the most important part will be that we create two another objects, and those objects we will call this object will be used as movement borders or edge left, edge right, and we will double this, we will copy them, we will name them end left and right. We will use them to determine within the scene from where to where the skeleton is free to move. To better have a look on those, we will change we will select the icon within the inspector. You can click here, drop the menu, and then for example, for the edges, we will use orange, and for the ends, we will use red. So, yes, and then we can change the positions. For the end, we will set -10, and for the end right, we will set 10, and for the edge, we will set it to, let's say, -7 and 7. So now you can see our we will create a script in the next step. And the script will manage that the skeleton can move within the orange borders, and when the player enters the red border, the skeleton can also move up to the red border. And when the player is leaving the red border again, the skeleton goes back to its normal behavior and only walks between the orange points. So let's go into the scripts folder. Within the scripts folder, we create a new folder called enemies. Within the enemies folder, we create a folder called skeleton. And within the skeleton folder, we create a C# script called skeleton behavior. Now let's go to the skeleton object, add a component called skeleton behavior, and then right click on that component and click edit script. So we are now within our skeleton behavior script, and we will paste following lines. We will give to the game object inspector two headers. The first header are the movement borders. There we will use the game object that we layouted in the scene just recently, the orange and the red points, and we will use another header under which we will identify the enemy object. We will have a float that we can adjust for the speed of the movement, and we only have to say which game object is the player. We will select the rigid body of the enemy object, and then we will use a bool for right, indicating if the player is moving right or left, and we will use a bool player inside, indicating if the player is inside the borders. In the start function, we will say player find the game object of the player by the name player. And that is correct for our scene as well, as the game object of the player is called player. Then we will use the player movement script, which is called differently here, I guess. It's called player script. So let's this adjust. We don't seek for the player movement script, but for the player script. And in the last step, we use the rigid body 2D of the enemy object. Also for the next step, let's change update into fixed update. Before we go towards the next step, let's include two additional bools called right check and left check. So in the next step, we will use these lines within the fixed update class. We will make an if statement asking whether the player is within the edges of within the edges of the movement borders of our enemy. If that is the case, we will use the command rb velocity to set a velocity to the enemy rigid bodies, so that the enemy is running towards the player. If this if statement is false, the player isn't inside the movement borders of our enemy, and our enemy will just run from left to right and from left to right and right to left. And this will managed here, where we set the velocity given these the directions. For the direction change, we will use the transform rotate command, and we will use the right check and the left check for that. Save this now. I will put a link in the video description to this script on GitHub, so you can take a look in the GitHub folder and copy the lines of codes. Also, the whole project I'm creating here, I put on GitHub. Feel free to check it out. You can copy these codes and lines and scripts as well. So now let's go back to Unity, and what we have to do now is give our skeleton a rigid body 2D, and here we have to freeze the rotation and freeze the position on the y-axis, so that our skeleton is only moving on the x-axis. Somewhere in the code I left a wrong name for a variable in line 47 because I changed German to English variable name description. So we adjust that, then we save the script and we go back to Unity, and I hope there are no errors left. And now we have to assign the variables in the skeleton behavior script. So we have our edge 1 here and our edge 2 on the right, I think, and the end left on the detection edge 1 and the end right on the detection 2. And we have to assign the enemy object, which is our skeleton, and we set our speed to, let's say, 2 for the test. Yeah, at this point we maybe can save the Unity project and we just test the scene. Let's take a look. Yes, and it's working fine so far. So if we are within the detection radius. So skeleton is moving towards us, and if we go outside the detection area, you see the normal behavior of the skeleton. Now let's make it this way. If I move the player within the detection radius, you can see that the skeleton is changing its behavior. But you can see that we have to include the animation, the correct animation, into this skeleton. And since the skeleton is always walking, for the start it's enough to just change the animation to the walk animation. For that, let's go into the sprites folder. Let's go into the enemies folder, into the skeleton folder, and then we have our walk animation. We select all 4 sprite images, drop them here. We save the animation as walk animation. Now we have two animators. Let's rename the walk animation manager into skeleton animations. Now let's go to the skeleton object and drop into the animation controller the skeleton animations. Now let's get back to scene. We can delete the object walk 0, underline 0, and let's take a look on our skeleton. And you can see he is walking. It looks very okay, my opinion. And that was the content for our episode today. So we created the behavior, the movement behavior of our enemy. In the next episode, we have to add a script on the attacks of the skeleton and the health management system of our player. Maybe I will even subdivide this. I'm not sure for this. I don't want to fit too much content in one episode. But that is the content for our episode for today, and I hope you had fun to watch this tutorial. If you have any comments, feel free to put them into the comment section of this video. You can also join on my Discord. The link will be in the video description. If you want to reach out to me, feel free. And yes, thank you for watching, and I hope we will see you soon.